So today we are going to talk about weather fronts. So the whole reason to pull it all together here is we talked about air masses last time and all that, but now we need to talk about what those air masses really do in order to then start looking forward to how does it all connect in order to fully explain and start working towards that predictability of weather and forecasting. So we're working with Middle School Earth Science Standard 3-2, which states you'll be able to explain how the motions and complex interactions of air masses result in changes in weather conditions. Basically, what you're going to be able to do by the end of this is identify the different types of pressure systems. There are 2 different types of pressure systems, but then also identify the different types of weather fronts. There are 4 of them, and what weather typically comes with them, or what's before versus after each front, and all that kind of fun jazz. So let's get going with that. There are 4 different ways for you to be able to take your notes today. Just make sure if you choose after whole group to do your doodle notes or do these all digitally, that you have the correct pages to go with them, including the whole group slip. So, the importance of pressure systems. So we talked a little bit last week about pressure systems and how they play a role. We need to remember that we are feeling air pressure at different points within our atmosphere. So down at sea level, we have the most amount of air pressure occurring between the mass of the atmosphere above us and the gravitational pull of not only the Earth, but our sun and all that jazz. So as we move higher up into our atmosphere, we are feeling less and less air pressure, which then helps play into the difference in temperatures and all this, which then just brings in weather. So all pressure systems are associated with a type of pattern within our weather. So let's talk about these. So high pressure systems, the way I have remembered them kind of, I guess, is when you feel high, like very positive, if you're thinking emotional, mental health sort of stuff. When you're feeling high, you're feeling good. It's a wonderful day sort of a thing. High pressure systems bring in those clear skies and fair weather. It's the days you want to be outside. Because what's happening is the air is being sucked from the very top of our troposphere, which is very, very light and very, very cold, sucking it down towards the surface, bringing down that dense, cool air, very minimal moisture, so that minimal clouds can actually condense. You don't really have extra precipitation to where you have rainstorms and things like that. And it pulls it down and it moves in an outward motion to keep those areas, those clear skies, fair weather, all that kind of jazz. So again, high pressure system I associate with high mental well-being and positive, clear, fair weather skies. Low pressure systems are just the opposite. So if you think of high pressure systems being super positive, super yay, I want to be outside and do all this, low pressure systems are the bleh sort of systems. So what it's doing is it's pulling air from the surface, which is warmer than up in our troposphere, and because it's warmer, it can hold in more moisture. It's pulling it up into the really cold troposphere, which then causes all that extra moisture to condense and turn into clouds. And the more moisture we add to that, the less the clouds can hold, to where then we start seeing rain or precipitation of some sort. So low pressure systems come with cloudy chances of precipitation, those sorts of things. So when you're feeling low mentally, you're like, bleh, I don't want to really do this sort of a thing. That's kind of how low pressure systems act, oddly enough. So that I had a student who said, well, it's the difference between eating, their example was spaghetti and peas. Spaghetti makes you really happy. So if you think of like happy comfort food sort of a thing. You think of high pressure systems. Low pressure systems would be like the peas, or a food that they don't necessarily enjoy nearly as much. So kind of that bleh sort of thing. So whatever helps you, I guess, associate one with another, and that's up to you. So as you move into independent work, just remember your champ's expectations from around the room, and if you need anything, just let me know. If you're going to continue with PowerPoint notes, then hold on a second, we're going to keep moving. So air masses, we talked about this last time. Air masses are large bodies of air that have a uniformed weather property throughout. So continental polar, continental meaning it forms over a continent, which means very, very dry. Polar meaning cold because it came from closer to the poles. As that comes down, it's dry, cold air, that sort of a thing, for the most part throughout that entire air mass. Maritime tropical, maritime meaning that it is formed over water, tropical meaning warm, and because it's warm it can hold so much more moisture, so as it pulls up it can then bring more moisture onto land and things like that. So all of these bring in some sort of weather. We have to remember that weather is almost a minute by minute sort of thing, versus climate, which is far longer of a period of time. But these air masses move in and they're here for a minute, they're here for an hour, they're here for a day. But that's kind of how weather works. So air masses are classified based off of their temperature and their moisture content. So like I've already explained, continental polar means you have cool air that is formed over land toward the poles, and then it works its way in whatever direction it's moving. Continental tropical means, oh, that's not supposed to be continental tropical. That is supposed to be polar tropical, or maritime tropical. Goodness, no, I am right. Just a goofy day. Continental tropical means that it forms over landmass, but in a warmer climate to where it brings on that arid sort of desert sort of thing. That's why if you go down to like the southwestern portion of the country, it's hot there. It's really hot, but it feels so much different than our hot because it's dry versus humid, which humidity just increases temperature that much more. Versus continental tropical, it's dry, so it's the ambient air temperature sort of a thing. Maritime polar means that it formed over the cooler parts of our oceans, so it brings in moisture, not as much as, say, a maritime tropical, which is forming over warm water with warm air masses, to where then it just makes it be able to become more and more saturated. Now, all of this is important beyond the fact that I just feel like I rambled, because as those different air masses move in, or like one comes up behind it in line sort of a thing, it causes what we call fronts. So fronts are that boundary between air masses. I like to think of it kind of like a line of kindergartners. So you get a line of kindergartners, they're all kind of moving at their own little rates. And when they are moving at different rates, you have one that runs into another. You have one that is so far apart from the next that they're just taking their time, that sort of a thing. But if you think of the ones that collide with each other, whether it's the really, really fast one getting ahead and then running into the next one in front of them, you get dramatic weather changes. And by dramatic means that you have something completely opposite of what is going on. And that's because when weather comes in from fronts, typically the opposite moves in of what was already there. Now, there are 4 different types of fronts that we need to talk about, and I promise it should all make sense by the end of it, but bear with me. So, a cold front. A cold front is where the air that has been over a specific piece of land has been warm. And then all of a sudden you're starting to get this cooler air moving in. Now, cold air, we're not talking the difference between our summer air to our winter air here, but rather it's a couple degrees cooler than what air is already present. So if it's sitting at a chill 75, 80 degrees, this is like that 60 degree sort of wind change moving in. And what happens is that cold air masses move much, much quicker. And that is because they're carrying less humidity, meaning that they can move a little bit easier, versus warm air is carrying a lot of humidity, which kind of weighs them down. So the cool air starts to move in very quickly, and then it runs into this warm air mass here, who's not moving as quickly. So when they meet, because cool air causes all moisture to condense, it starts to create these big old clouds, and it goes all the way up. Because there's so much moisture, it can just keep building on top of itself. Now, we call those clouds, just as a reminder, cumulonimbus clouds, and typically with cumulonimbus clouds, we see severe weather. This is the storms that send us into tornado warnings, or even into hailstorms, or like those really big dumping snow sort of storms that occur in the winter. And that's because warm air just can't move nearly as quickly as cold air can. Now, if we were to imagine a cold front moving in on a meteorological map, so if you tune into Valley News Live, sort of a thing, you're going to see a picture of our continent, and then you are going to see lines like this. Now, to represent a cold air front, it's like mountains. Okay, and typically it shows up in blue, but they're always pointed in the direction in which the mass is moving. So this mass would be moving in this direction, but this is a cold front. Okay, now I always think of them as mountains because the higher you get in a mountain, the cooler it gets. That's why you can have snow caps and things like that. So this is the symbol you're going to see. So this is the diagram. You might want to pause me for just a quick second so that you can draw this out. And by draw this out, I mean like add in this line and then your cold arrow and your warm arrow going up, things like that. I'm not looking for anything elaborate with trees and whatnot. But so hit pause if you haven't written this all down or diagrammed it out, and then we will continue on. So warm air fronts. So warm fronts move in much slower than cold air fronts, which is fine. But it allows them then to have this gradual incline. So with the cold air front, you had that like quick little hill humpity thing. Well, now this is just slowly rising because warm air wants to rise, but it's still coming in contact with that cold air mass, which still creates this precipitation and clouds and things like that, but it's more like the stratus clouds, to where you're going to have those rainy, cloudy sort of conditions, but it's going to be that warm and wet feeling afterward that's just humidity gross. Because it can take a little bit longer for the warm air front to actually take hold. So similarly to the cold front, when you see a warm front on a weather map, you see it with this symbol. It's a little hill, or as I like to call it, it's like a sun, because typically warm masses bring in warmer air, which to me looks like a sun. So this would be your warm air mass. So again, diagram and your symbol. So pause if you need to and come on back. After the warm air settles in, this is again just that like wet, muggy, like you walk out of your house or into the bathroom after someone has taken a really long hot shower sort of a thing, and it's like you run into a wall of rain. It's just not fun. This is typically what our summers feel like. Stationary fronts. Stationary fronts are when a cold air mass and a warm air mass are actually moving toward one another. Now, this doesn't happen that often, but you get a weird jet stream and some things just get wonky. So what happens is that they are both fighting to take over the same area, to where you get these days upon days of rain because they're stubborn. They don't want to move. They both want to take over, and depending on whichever front was stronger to begin with, meaning it had more mass behind it, they're the ones who end up winning. So if there's more cold air moving in, then there is the cold front will eventually take over versus the warm air with the warm front. So when you see this appear on your weather screen, so in this case it would be you have your mountains for your cold air moving in this direction, okay? And then you have your warm air masses trying to move in this direction. So they're fighting each other for similar space, okay? So simple as like a book page V sort of a thing, and then draw your diagram. Okay, there's one more air front that we need to talk about, and that is called included. And as we've been saying from here, like from the beginning of this, cold air masses tend to move much, much quicker than warm air masses. So this is like when you are in line, or you have those kindergartners in line, and the one behind you like flat tires you to where you just kind of stop in your tracks. So the warm air mass kind of stops, but it goes up above the cold air mass to where that cold air mass keeps moving in the direction it's going, and the warm air mass kind of just doesn't know what to do with itself. So it hangs out on top because it's less dense, so it's easier to just kind of head up in that direction. This brings on precipitation, and typically it's precipitation for days. So if you're thinking right now, this is what happened a couple of weeks ago where we had that cold air mass, because even when you went outside, it was nice and cool, and we've had cool weather since. But all of those rainy days. So when you see this on your weather map, you're going to see it with a mixture of the little sun pieces and the mountains, because it is a cold air mass and a warm air mass moving generally in the same direction, but the cold air mass is what takes over. So all of this is important to know, because this is what meteorologists look at in order to start to determine what is our forecast going to look like in the next couple of days. How quick are the warm air masses moving in comparison to the cold air masses? So then it tells us, hey, expect rain, and expect rain for a day, or hey, expect rain for like the next month, it feels like. So yeah, so that's what leads us into being able to forecast, which we will talk tomorrow. If you have any questions, please let me know. Thanks.